Thank you very much. And a big thank you to BioMarie for the invitation. It is really a great pleasure and a honor to be participating in this great event for the second year. Today, the topic of our discussion is about war. This is the war between beverage industry and microbial biofilms. And the question I would like to set for today is related to the decision of moving from firefighting to prevention. So what is better, to stay with firefighting or to move to prevention strategy? Any ideas? Yes, the decision is, and the answer is quite simple. We must move to prevention strategy. And the reason is very simple. I mean, who is going to the battle? Who is going to the war with a fire extinguisher? I think it's not making sense. So we must move to prevention strategy. Actually, in Coca-Cola Hellenic, we have identified 3 very serious reasons for doing so. First one is related to the dimensions and the extension that this war may take. Coca-Cola Hellenic is operating across 3 continents in 29 countries, producing in 62 plants in order to serve a market of more than 700 million consumers on a daily basis. So I think it would be quite a challenge if we tried to go to such wide battlefield using fire extinguishers. It would be very difficult. The next reason is related to what are the probabilities to get attacked by microbial biofilms and by microbial risks and incidents. As Tatiana explained in the morning, we have consumers that are moving towards more and more sensitive food and beverage. Accordingly, Coca-Cola Hellenic has adjusted our portfolio to preservative-free products, energy drinks, juices, waters, vitamin water. All this portfolio is very much exposed to all different kinds of microbiological risks. And the impact of a microbiological biofilm, in this case, can be severe. So this is the second good reason. We are exposed to high risk. And we cannot fight high risk with a fire extinguisher. The third reason is related to business. It's a business decision if we are going to stay with firefighting or we need to move to prevention. And as every business decision, there is cost involved. So what costs more, to go to firefighting or to go to prevention? Because prevention sounds very nice. However, there is cost behind, and this cost is not negligible at all. So let's try to calculate. What is the cost of poor quality? What is the cost of a quality incident, a micro-related quality incident in beverage industry? We can say that the cost can be tangible and non-tangible. So under the tangible part, we would calculate cost for product destruction, cost for product withdrawal, cost for sorting, for additional testing and retesting, and testing again sometimes. We would also have cost probably related to claims, legal claims or consumer claims, cost coming from additional tests introduced in order to ensure future productions, cost related to quarantine of product, and all this is increasing and increasing. But how can we calculate the cost that is related to the damage that will occur for the brand name? After we have a quality incident in the market, the brand gets damaged. And it will take years and years to recover if it will ever happen. And I would say that the price, the value of company reputation and brand reputation is beyond any other value or cost that we can measure. Therefore, the decision-making is clear, and I would say that the bigger is the size and the complexity of the company, the less negotiable this decision is. So we must move from firefighting to prevention when it comes to microbiology and quality incidents in general. But is it a realistic decision? So it is really possible to control and prevent quality issues. I would say that if we take out everything that is related to human factor, so operator mistakes, operator practices, even the part which is related to organizational culture, then we are left with more clear root causes that are leading to microbiological incidents. And those are either related to performance of equipment or design of equipment, failure of process control for critical equipment we have in production lines, or that is related to cleaning and sanitizing program gaps. So keeping this in mind, Coca-Cola Hellenic has developed a strategy, a prevention strategy, aiming to eliminate these three areas of the root causes that are more easy to manage, because as we said, the human factor is the most difficult, the most challenging one. So we have created this strategy under the name of Critical to Quality Preventive Maintenance Matrix Program. What is this? This is a program that includes several maintenance activities related to critical equipment of the production lines or critical process steps, aiming to ensure resources availability in order to implement those maintenance activities, and also to ensure very stringent monitoring of the implementation. The final scope, of course, is to stop having a repetition of quality incidents that are related to the same root causes. This program is an alive one. This is continuously updated in order to include learnings from new quality incidents that are happening internally in Coca-Cola Hellenic, because we have incidents, and also externally. So we are collecting experience available across the beverage industry system. And our tool, our program, is also continuously updated in order to include the new technologies and the new tools that are becoming available day by day, year by year, and can be used as prevention weapons in this battle with microbes. This is a snapshot. This is a summary of how this famous critical to quality preventive maintenance matrix looks like. It's nothing sophisticated. This is just a matrix listing critical maintenance activities related to critical process steps or critical equipment. So we have different activities for the different technologies and different production lines available in each plant. And we are also defining the frequency for implementation of these activities. The frequency is decided based on a risk assessment methodology. So for every plant, we know what technologies are available, what is the equipment, we know immediately what activities we need to implement and with what frequency. In the following slides, I will focus on some of the most powerful tools related to biofilm prevention that are included in our critical to quality preventive maintenance matrix plan. I will start with, let's say, the core. And the core for biofilm prevention is the CIP and COP validation programs. The CIP validation, what is this about? This is about checking and verifying that the CIP parameters, the specifications, are met for each one of the CIP loops in the plant. And why is this so special? I mean, in most of production facilities where we have a CIP loop, we have the capability to monitor continuously the performance of CAP. So you have thermometers in place, you have conductivity meters in place. Why do we need to validate? Because the parameters may change across the CAP loop. We may have a flow change that we are not aware of. Why? Because we may have changes in the diameters of the piping that is connected to the equipment. We may have even changes at the concentration of the chemicals. Why? Because we may have foaming during the recirculation of the chemical, or we may experience turbulence. So for this reason, it's very important to have evaluation of the CAP parameters and the specifications at different points across the CAP loop. Under the CAP validation tool, we have also the famous hygienic check. Hygienic check is a check of all the plant, end to end, looking for dead legs, looking for improper connections, looking for leakages, flow splits, looking for different events that may impact the performance of CAP. This is the hygienic check. On the side of COP validation, what is COP validation? This is primarily a dye test. This is a spray shadow test which is applied in all areas that are cleaned through COP systems. We spray a specific dye on the surfaces of the equipment, and afterwards we activate the COP system, checking for any residuals remaining from the dye that we applied before. This is indication that some of the areas are not properly covered by the cleaning mechanism. We also have hygienic check for the COP system, and this is including also dead legs that may occur on the COP system itself and can be really very, very risky. It is included checking of all the surfaces for any damages. You can check for weathered surfaces, pinholes, especially when it comes to plastic parts or silicone parts, rusty surfaces, scaling, because all these can be sources for the startup and build-up of biofilms on the lines. This is the CAP and COP validation program. The implementation frequency is minimum once per year, but can be more frequent in plants where we have identified different level of the risk, for example, in aseptic plants, juice-producing plants, or natural mineral water plants. The next program to share is the process flow control. This is a program including all the activities related to calibration, validation, and verification of equipment that is either part of the HACCP plan in the plant or has been identified as critical equipment to control important processes in the plant. As an example, under the process flow control, we have all the calibrations and verifications related to instruments controlling the CAP in the plant. For example, here you have the flow meters of the CAP, the thermometers, the conductivity meters. So whatever instrument is identified as critical one is having a maintenance plan that is monitored and controlled under the process flow control program. Next one, life-saving one. This is integrity test performed for heat exchangers, aseptic tanks, and isolators. This is a life-changing and life-saving program because it has prevented disasters, at least when it comes to our company. This is a program that can help you to early detect any potential source of a biofilm or biofilm risk. For the isolators and the aseptic tanks, the integrity test is performed by application of a special dye, which can be then detected using a UV light of special wavelength. This way, we can understand if there are any cracks, any pinholes, any scaling, any residuals, even early start of biofilm on the surfaces. The integrity test when it comes to heat exchangers is performed by application of a high pressure of nitrogen gas. There we can understand if there are any cracks or any pinholes where we could have the startup of improper cleaning and startup of biofilm formation. Very important tools, very useful tools. This is a very recent addition to our critical to quality preventive maintenance matrix. This is the so-called hygienic audit for processing and filling of aseptic lines. This is actually an end-to-end hygienic inspection in plants where we have aseptic processing. It includes, among others, cross-check for the implementation of preventive maintenance. It includes dismantling and verification of the condition of long-lasting parts. When we are operating an aseptic line, maybe you have in mind how a Tetra Pak line looks like and how the preventive maintenance plan for a Tetra Pak line looks like. It is based on operational hours, and some of the parts there is no need to change for several hours of operations, which can be even years. So we take the opportunity of the hygienic audit program to dismantle and verify that really the condition is the expected one. This hygienic audit also includes a check of any alarms that can be related or could be impacting the aseptic processing, and they are not critical ones, because when you have a critical alarm at the line, then the line stops. If the alarm is not critical, but it is repeated, it might be a signal or an alert that something is going wrong with the aseptic conditions on the line, and there might be some risk. Another very useful tool is the pipeline mechanical cleaning. This is a very useful tool that we apply in case the CIP parameters cannot be guaranteed across a CIP loop. And we have such cases. We have such cases when the piping is, for example, very long. Imagine a pipe that is connecting a water source with a production plant. That can be several kilometers long. It's not possible to achieve a proper CIP flow, minimum required flow, or to achieve a proper temperature across a so long piping CIP loop. Recirculation is not even an option in such cases. And we can have these long pipings or pipings with U-turns or sharp corners, even as installations inside the plants. And there you cannot achieve a proper CIP recirculation flow and conditions. So for these cases, we are using the famous pipeline mechanical cleaning. This is a method called also pigging, which is using soft sponges that are pushed through the piping using the water supply or using the chemical supply if we want to achieve disinfection at the same time. So the sponge is pushed through the piping, causing mechanical effect on the walls, and we can achieve removal of biofilm at early stage or proper cleaning where CIP is not possible to apply properly. The old-fashioned method is with sponges. The modern method is called ice pigging and is using a mix of ice with cold water, like a slurry, which is pushed through the pipe, and with the particles of the ice, we achieve the mechanical effect on the walls of the pipeline. The tools that I have presented so far are more or less known in the beverage industry. Maybe not known under a holistic concept like the critical to quality preventive maintenance matrix that I present as our strategy, but as individual tools, I believe that many of you are familiar with them. They are available for many years. In the next slide, so for the last part of my presentation, I will refer to a tool that is not so popular yet, but if we consider what is the potential, what is the dynamic, and what is the need in the industry, I can predict with very high accuracy, that in the next years it is going to become a frontline weapon against the biofilm war. So let me introduce the molecular mapping tool. Why Coca-Cola Hellenic and how decided to introduce such a sophisticated tool, such an advanced tool at industrial level? The reason behind is that we are very well aware of the serious limitations related to conventional microbiology methods. So what we actually need in beverage industry to use in prevention for biofilm is a tool that will be sensitive enough to detect very small changes in the microflora and the micropopulation at the different process steps inside the plant. With conventional microbiology, we cannot get such information. Why? Because many of the species are not growing in our media. So it's a challenge to recover the microbes that are present in the raw materials, in the process steps, in the rinsing water, in the equipment. And then the population can be significantly underestimated. So we don't have a clear picture of what microbes are present in the plant and what exactly is their level at each different sample or process step. How the molecular mapping tool works. The idea is that we collect samples from different process steps. We can target samples of rinsing water after the last cleaning or sanitizing of the equipment. We can target samples of raw materials, so it can be juice concentrates, it can be water, it can be sweetener solutions, and we can also target samples of final products. This way, we can get a full map of what species, microspecies, are present at each different process step and each different sample in the plant. So we have a map of who is where, who is increased at what process step, and who is absent or when some new species is introduced exactly during our production process. It all starts by a sample. It can be rinsing water sample, it can be a swab, raw material, whatever. There is really no limit with this method. What we do, we perform a total microbial community DNA extraction out of this sample. All this DNA that is recovered is then sequenced. So all the rRNA genes that are present in the sample are sequenced, and we get a comparison of the sequences versus available databases. This is how we have the full name of the microbes that are present in each one of the samples. And based on the number of the copies of each different gene of rRNA, we are able to know how many times each one of the species is found in the sample. So we know, for example, that Sebastian, in rinsing water sample from the tank, is present 10 times. When we move to the swab from the filling equipment surface, the very same species is present 100 times. So it's not only that we know who is there, but we also know how many times, or what is the frequency, what is the abundance of each one of the species at each point of the process step. What we have seen, what we have realized is the expected one. So molecular microbiology mapping is an extremely powerful and sensitive tool. We have seen samples from where we were able to isolate less than 10 microspecies, coming with thousands of microspecies. So the level, the depth to which we can go is really impressive. The real picture is revealed with the molecular mapping tool, while with conventional methods, we only have a small part of what is happening in reality. If we put all the information we collect from the different process steps together, we can create a color map. So we can see what species is present in low frequency with low abundance in one part of the plant, where it is increased, and when it is absent or when it is entering. So we can have a very powerful tool to understand where we have biofilm risk. For example, if you see that some species which has a certain level of presence is suddenly accumulating and the population is increasing, this can be immediately indication that there is a biofilm starting to build up at this process step. Or if you have, for example, some spoilage, some contamination in the final product, then you can immediately connect this contamination with the different process steps or the raw materials, having the full map of what is causing the spoilage and where in the process this spoilage species is present or when it entered. Also, we can make conclusions related to the thermal processing effectiveness, efficiency. So if we see that all the species coming with the raw materials are addressed and we cannot anymore detect them in the final product, it means that our thermal processing design is capable to address all the risks that we receive with the raw materials. Let's see some real results. And the results are super, super hot out of press, just received a couple of weeks ago from Biomérieux laboratory. So what we have here? We have here the comparison of the microflora present in 3 random syrup samples, beverage syrup samples, versus the microflora that is present in the rinsing water collected out of the syrup tank after CIP. We have good news and bad news on this slide. Let's start from the good news. The good news is that our cleaning program is effective. Why? Because we see that none of the dominant species, what we have in the syrup, in the beverage syrups, can be detected in the rinsing water after CIP from the syrup tank. So whatever was introduced in the syrup tank coming from the raw materials, it's eliminated after we apply the CIP program. This is the good news. The bad news is that we have a biofilm. How do we know we have a biofilm? If you see on the right side of the slide, you see that in the rinsing water, we have a very dominant species of bacteria recovered. Dominance is not something which is occurring in nature. When you have dominance, you have indication of biofilm. In nature, we have very high levels of biodiversity. When one population starts to increase versus all other population, it means dominance, and this is a very strong indication of biofilm. So good news, we are cleaning effectively. Bad news, there is a biofilm somewhere in the water supply pipe. And how can we find out which of all the pipes in the plants has the biofilm? Here we can use the example of 2 pipes where we have compared the microflora at the sample from the pipe outlet with the microflora with the sample at the pipe inlet. So on the right side, we see a pipeline that is fine. Why is fine? Because we see that the level of population for the different species is more or less the same. So we have this strange bacteria of GW species something. The population level at the inlet of the pipeline is around 15, at the outlet is around 17. This is not significant difference, which means there is no accumulation. Whatever bacteria enter, the same bacteria we have at the outlet of the pipe. On the left side, we see a pipeline with a biofilm. How do we know there is a biofilm? If we compare the microflora at the pipeline inlet with the microflora at the pipeline outlet, we can see that there are certain species appearing with very high percentage versus the inlet sample. This is indication that we have species accumulating inside the piping. They have established there, they have started building their houses, their small villages. We have a very nice biofilm. So good news and bad news in this slide as well. Bad news, we have a biofilm. Good news, we have several tools that enable us to remove the biofilm. So we can use the famous pipeline mechanical pigging, or we can use more sophisticated tools like the ones we will see in the afternoon for biofilm removal with enzymes. Good news and bad news. More hot results. Here we have results from raw materials. We have analyzed the microflora, we have created the molecular maps out of different juices coming from different suppliers. Why this information is useful? This information can be used in several ways. As I said, there is no limitation on how you can use this molecular mapping tool. Looking at historical data for the different juices and what species we can find in these juices coming from different suppliers and different supply points, we can build a very effective thermal processing in the plant. So we know exactly what are the species we want to address, and we can decide and we can design a tailor-made thermal processing that will help us keep and preserve the freshness and the taste characteristic of the juices, addressing at the same time the risks that we have seen or what we expect to see coming with our raw materials. So we can build the thermal processing. We can also understand what is the frequency and the risk level when it comes to heat-resistant microorganisms. So we filled in the survey, is heat-resistant molds a risk for beverage industry? Using this molecular mapping tool, we can reply with very high precision. Why? Because we know what we receive. And we know, for example, that heat-resistant molds we rarely see in our samples of incoming juices. Or we see with very high per frequency lately when the juice is coming from that area of the world. Or we see that, yes, there are heat-resistant molds, however, the level is always very, very low related to the rest of the microspecies in the sample. So we can get better understanding of the risk. The molecular mapping tool can also be very useful information for the supplier's evaluation. So when we want to design our strategy, what are our suppliers? We can get information about the hygiene level at the juice concentrate plant looking into the results of molecular mapping. You can immediately see if you have, for example, enterobacteria presence, or you have high level of spoilage microbes, you have high level of lactic acid bacteria. Then you can immediately understand that the conditions and the process control is not at good level at the supplier manufacturing plant. So the juice concentrate plant has to be improved. What else? If you look into the results and historical results coming from the suppliers, you can even understand or identify new risks that you don't expect or you are not aware of. You see here in the latest results we received, we detected one supplier, one certain juice concentrate, carrying virus DNA. This is something that you don't expect. In the juices, you expect to have molds, yeast, some bacteria spores, but not viruses. So this tool enables you to have a clear picture of the risks, to understand better the risks and be proactive against those. Not to mention that by retaining, and I think that all of us are retaining samples of raw materials used in production using a freezer, then you may activate a very powerful troubleshooting tool at any point. Let's suppose that you start receiving complaints about a juice that we filled 3 months ago. Immediately, we can go back to our freezer, retrieve the sample, the retained sample of the juice, the raw material used, and we can activate the molecular mapping tool. We can get a full analysis of what species are present in this retention sample, what are the spoiled species we see in our final product, and then from this comparison, I understand clearly if the raw material can be related to what is the spoilage problem in the finished product. And this can be, I would say, the most objective input to any arbitration process. So it's very clear, very pragmatic, and nobody can raise any questions related to this. I'm very enthusiastic about this tool. This is a tool that, as I said, has unlimited applications. It's only a matter of imagination, understanding of the special needs in each industry and each production plant, and there you can use and get all the answers to almost any problem. Coca-Cola Hellenic has been using this molecular mapping tool. We started in 2013. In the beginning, we were using only as troubleshooting tool. So in order to investigate and resolve quality incidents, microbial related quality incidents, we were going to molecular mapping. Very soon, I would say around 2015, 2016, we introduced this molecular mapping tool as part of our critical to quality preventive maintenance program. And today, this is part of the biofilm prevention. It is mandated, as I said, across all our plants producing sensitive beverages. Up to now, it was water. Now, started working over the last months to introduce it also for juice plants and sensitive beverages. And just to conclude our discussion, I think the decision is clear. We must move from firefighting to prevention. I gave you already 3 good reasons, cost included. And yes, it is possible to prevent quality incidents. And we are very proud to see that by implementing this critical to quality preventive maintenance matrix program, we have achieved reduction of micro-related quality incidents up to 80% with only 3 years of implementation of the tool. And we are even more optimistic that by keeping this program alive and continuously introducing new learnings, internal or from across the beverage industry, and of course introducing the new tools and new methodologies as those become available for the prevention of micro issues, we can become even more efficient and improve further our quality. So thank you very much for your attention.